Hi everyone, welcome to my channel Code with V. In the previous video, we have seen what are higher order functions, how we can create higher order functions using functional interfaces, and how to call these higher order functions using lambda expressions. In this video, we will see more advanced use cases of higher order functions with the help of Stream API. Before we start, let's look at one of the problem statement. Suppose we have a ball type and we want to transform this type to the ball type but with different color. If we have to do it in Java, we can simply define one method. We can pass the ball as an input and then we apply a change color and return the ball. Or we have more functional way in which instead of changing the existing instance, we will copy that instance and then apply the changes on the new instance and return the new instance. What if we have those objects within a container? We know how to transform a single element, but when it comes to the container, how can we do that? By container, I mean list, set, or any kind of collection that you have. We can simply define one array list. Iterating through the existing collection, we can get one element at a time, apply the change. So in this case, change is change of color, and then add that instance to the colored balls list and return the colored ball list. So in this case, we will have two array lists. One is the existing balls list and another one is the colored ball. Now, if we change the transformation to change of size, so instead of changing the color, you need to change the size of the balls. Again, you will have to do the same thing. Only difference would be that you need to apply a change size instead of change color method. We are writing each and every step in your program that you need an array list. Then you need to iterate through each ball in the existing array list and then get one element, apply a change, add that to the new list and return that list. In this way, we are telling our program how to do it. What if we could write our program in this way? So we have the collection of balls. We want to transform it and the transformation is in the form of change color. Or we want to transform and the transformation is in the form of change size. Moreover, if we need to apply the two functionalities, so we can simply write a program, balls, transform, change color, change size. So we are telling our program what needs to be done. While looking at this program, it is clearly identifiable that what it is doing. It is transforming, changing the color, changing the size, and you're getting the list of balls. Can we really do it in our program? This is all about the function style of programming. The function style of programming is telling the program what to do rather than how to do it. But how can we achieve this? To write our program in this manner, we need higher order functions. And we have already talked about higher order function in our previous video. So for our problem statement, we needed to apply some kind of higher order functions. But Java is object-oriented programming language by its design. Collection does not have any higher order functions. Java did not have any functional concepts in it. But with addition of Java 8, Java got the functional style of programming in it. And we have the Stream API that can provide different kind of higher order functions that we can use in our program. Java Stream represents a pipeline for flow of the data, and it also provides the different higher order functions that can be operated on the data. We have a source, we pass it on to the stream, and then we apply different higher order functions in it, and eventually we get the data out of the stream in the sink. So source is your input and sink would be your output. When it comes to higher order functions within stream, so there are lots of higher order functions. Few of them are map, filter, flatmap, reduce, count. So we will talk about some of them today. So how Stream API works is you have a source. First of all, you convert that source into the stream with the help of Stream APIs. And then you chain different higher order functions with your stream. And finally, you convert that stream to sync again with the help of Stream APIs. How can we convert our source into stream? For that, there are different APIs. If you have some objects and you want to create a stream from it, so you can use of method of stream and you pass your objects to it. It will give you stream of objects. So here in this example, we have passed integers to it. So it will give you stream of integer. Similarly, if you have the array and you want to convert that to stream, so you can use arrays.stream method. If you have some collection, so you can use stream method on that collection. And if you want to generate a stream of random number, you can use generate method of stream and it will give you the stream of random data. And to get out of stream, you can apply the stream methods such as toArray to convert stream to array, collect to convert the stream into list, set, map, or any other collection. So there are lots of other stream APIs as well, which you can utilize to get the sync out of your stream. Let's look at one of the higher order function, map. In stream, we have map method, which is a higher order function, and it takes function as an input. So function is a functional interface. This is what we have already discussed in our previous video. If you have a stream of type T, so you can pass any lambda expression to it, which takes T as an input, and that lambda expression returns the R as a type. Then the type of your stream after applying this map would be stream of R. For our example, we can pass a lambda ball to change color ball to get the stream of balls with the changed color. We will see some practical example where we can use map. For our example, we have created a ball type. This ball type has some attributes such as type, color, size, and weight. So here we have created a list of ball that has different kind of balls in it. And now our purpose is to change the color of balls to green color ball. We have some assertions over here. So all the colored balls has the type green and the existing ball instance remain same with the default color in it. So it won't have the green color at all. Here we want to apply some higher order function in the list of balls. So whenever we will apply a stream on the ball, so list of ball will have a type stream of ball. Okay, so now we have got the stream of ball, and then from a stream of ball we want to get the list of ball. From collection we can apply stream to get the stream of the type, and from this we can collect it to any type by using the collect method. So far this statement is simply same as the balls. We need to convert every ball within this balls list to the green color. Whenever we apply a map on a stream, so map take the functional interface, that is, we can pass a lambda expression to it. And for the input of that lambda expressions, the input will always be of the type of stream. So here we have a stream of balls. So this lambda will have an input as the ball type. And now, whatever is the return type of the lambda expression will become the return type of your string. We need a stream of ball. We need a list of ball, and this expression compiles and it has a type list of ball. But we have some kind of ball and we need to convert that to the other kind. We can use our method that we have defined to change the color. So it is within operations and we have change color method. So when we applied this thing, ball to operation.change color ball, so you have got the list of ball. We can easily construct this thing by looking at the type definition only. So we needed a stream of ball. We know balls.stream will give us that. We needed to convert it into the list of balls. So it will always remain same for you. Only part that changes is the transformation. Now, if we run this test, so test is successful. Whenever you have a lambda expression that takes some input and the same input is passed to the method that you are calling within the lambda, so you can use the method reference. So here, this means that it is taking some type T, which is the type of your stream, and it is applying that T to the method change color within operation. In this example, we have seen that we have applied map to get the list of ball to list of ball. In this example, we want to get all the colors of balls. So we have list of balls that contains different balls and we want to get the color of each ball. Again, we have to do the same thing. We have balls, we can apply stream in it and then we can collect it to the collectors.toList. So we had the list of balls. When we applied the stream, we got the stream of ball. And when we applied the collect, it will get us the list of balls. But what we want is list of color. So again, we can use map over here to transform the ball to color. For that, we have the ball instance as an input type because we have this stream of balls. So for the lambda that we are passing to map, we'll have an input type as ball. And to get the color, we can simply get ball dot get color. Replace it with lambda. When I run this, so we have got the list of color from list of ball, but it will give us all the colors in your balls. What if we want to get the unique colors? So for that, we have the same set of balls, and now we want to get the unique color. You will start with the balls and then get the stream. Now, instead of collecting that to list, what we will do is we will collect them to set. We will apply map b and b dot get color. Replace with this. So yeah, we have now in this set, we will get the unique colors. So instead of 4, we should get 3 colors in it. So this was about map. If you have a requirement when you have list of elements and you want to filter out some of the element from that list. So here, for example, we have list of tennis balls and the football, and we want to get only footballs. Then we can apply filter. Filter takes the predicate, and this predicate is again a functional interface. It takes some input and applies Boolean condition in it. So for our example, if we need to get the footballs, so we can apply a predicate, which is again going to be a lambda expression from type ball to the Boolean. Let's look at the code. So we have got the list of balls, and one of the ball has color blue, and we only want the blue ball. So we have balls, we have a stream, and then we want to collect it to list. We have the filter. It will again take a type T, which will be of type of a stream. So stream of ball. So this type is ball. And now we need to apply some Boolean condition over here. We dot get color, and that should be blue. And now run the test. So it should be green. Yeah. We have applied map, we have applied filter. Now we can combine both of these. So here we want to filter out the footballs, and at the same time, we want to change the color of each ball. So we have balls as the input. We will get a stream and we will get the list out of it. And then there are two operations that we need. We need, first of all, from all of these balls, we just need the footballs. For that, we know now we can apply filter, and this filter will take ball as an input. So we need to get only the balls which has a type football. So get type, and this should be football. When we apply a filter, it will again give you a stream of ball. We can apply map in here, and then this map will change the color of these balls. So operation dot change color. To make it simple, again change it to method reference. Let's run this test. That is working. Now let's look at the other problem statement. So we have a container, and that container contains other containers within it. To simplify it, we have a list of balls. In first list, we have list of tennis balls and we have list of footballs. Now we want to apply a change in the color of each ball. How can we do that? We have tennis balls and footballs. Those are contained within the list of balls. And now we want to change the color of each ball. So in the first list, we want to get the balls of green color, and we want to get the green color ball in the second list as well. We have list of balls as an input, and we want to collect it in the collector.toList. When we do this part, we will get list of ball. But here is the thing. We need to apply the transformation. For the transformation, we need map method. What will be the input type for this lambda expression here? Let's take this thing out. So we got the stream of list of ball. So this is stream 1 has a type of list of ball. So the input of our this map would be list of ball. So we have balls here. Yeah. And now we need to change the color of ball, and balls are within list of balls. So we can do the same thing as we have done earlier to apply a map for the transformation. So we have balls and we can apply the stream in it, and we can apply map here. And map will have the operations and then the change color. It is showing the compilation error, and it says that we have a required type list of ball, but we have got the list of stream of ball. So when we applied this collect method, it should get us a list of balls, right? It will convert the stream of type R to list of type R. But the type of this operation is stream of ball. So stream of ball, when collecting it, we will get a list of stream of balls. We need to get the list of ball. So we can collect it again, collectors dot to list. Okay, so when we get this, it should be working fine. Right. So this was about when we have a collection of collection and we want to get a collection of collection and do a transformation in between. So you can apply map. Now let's look at other scenario. So now we have a container of container, the same input, but the output that we want is we want all the different kind of balls within the different container. They should be part of the same container. So we need list of ball to list of ball. For that, we have another higher order function, which is called flatmap. It takes the function as an input. So again, the functional interface. It has a type T, which is the same as the map, but this function type has an output type, which is stream of type R. In map, whenever you are providing the lambda expression, you needed a lambda expression that converts type T to type R. What flatmap requires is a lambda expression that takes type T of your stream and returns the stream of R. And then the same type R will become the return type of your stream. So you will get a stream of R. Let's try to look at the example and we will understand it. So here again, we have the same list of balls. Now we need list of ball instead of list of balls. So we can apply a stream in it and then we will collect it, and the collection would be collectors dot to list. So it won't compile because the list of ball stream will give us a stream of list of ball. We need a lambda expression that take a type T and return a stream of R, and that is what our flat map does. So here we have balls as an input, and so balls is a type T, and we need a lambda expression here which returns a stream of type R. So we can get this stream from it. This operation is working perfectly fine. Whenever we need to get out the data from collections of collection, we can use flatmap. Our purpose was to change the color of each ball. We have a stream of ball and we want to apply a transformation, so we can apply that by using the operations and then the change color. Here you go. The difference that you can see here, we have applied a map and then map. So we got a list of ball. And when we applied a flat map, then map, we got a list of ball. Whenever you have a requirement that you have a container that contains some other containers and you want to flatten them up, always think of flat map. There are lots of other higher order functions. If you'd like to know more about them, please leave a comment below. If you have enjoyed watching my videos, please like it, subscribe, and share. And thanks for watching.